Here's Precalc. It's your lecture for 5.1.2. We're on problem 5-12. It says, can two different transformations give the same result? To explore this, consider this exponential function, k of x. Can this equation also be written in the form y equals a times b to the x? Work with your team to determine if it's possible to rewrite k to the x using only a vertical stretch. If so, justify your decision. If not, explain completely why it does not work. So I kind of already did it. I think I'll go through it like this. Okay, so I really want to just do some algebra, and I want to turn this so that it's rewritten like this one. So what I'm going to do is I'm going to work on using the laws of exponents. 2 is my base. So I can use the power property to make this 3 come on inside. So now I've got 2 cubed. And then I can turn 2 cubed into 8. And I can actually write this as 8 to the x times 8 to the negative 2. And then 8 to the negative 2 is 1 over 8 squared. And then so I can rewrite it like this. So this fraction right here is a. So I've succeeded in writing this as a times b to the x. So now we're on problem 5-13. It says, in working with exponential functions, it is not surprising that the properties of exponents are needed. Consider the exponential function f of x equals 3 to the x. Sketch the graph. Well, so the graph would probably it would go through 1, and it's just going to be an increasing graph. So I sketch the graph, and then it says, write an explicit equation and sketch for g of x equals f of x, or f of x plus 2, and describe the transformation. So g of x equals f of x plus 2. So that means I can put x plus 2, see x plus 2, I'm going to input that into the f function. So that's why I wrote it as 3 to the x plus 2. But then I remember back from my graphing form days that this is x minus h, you know, like y equals a times 3 to the x minus h plus k. So this is going to give me, it's going to move my parent function to the left by 2 because x minus h. I could also rewrite this as 3 to the x times 3 squared, and that would give me the 3 squared is a 9, and if I put the 9 out front, now it looks like y equals a times 3 to the x. Well, there's no h, right? So if I write it this way, it's like I have a stretch factor of 9. But if I just write it this way, it's like I have a horizontal shift to the left. And it turns out if I were to graph both of these on Desmos, algebraically, I hope you can see that they're the same. Graphically, they're going to be the exact same graph. So it turns out it's kind of weird with exponentials, but a horizontal shift can mean a stretch. Like you can write it either way. Now it's 5-13. So 5-14 says, let f of x equals 3 times 4 to the x. Use properties of exponents to show that each of the following equations is true. So they're saying f of x plus 2 equals 16 times f of x. And that's f of x. F of x is 3 times 4 to the x. So this right here is f of x for both of these problems. So I like to cover it up as I move along. Or uncover it, I mean, as I move along. So I'm just working on letter A here. So I'm supposed to show that if I plug in x plus 2 everywhere I see an x, then I'm going to end up with 16 times f of x. So I'm just going to start by plugging the x plus 2 in, and then I'm going to do that thing where I use the laws of exponents. So it's 4 to the x times 4 to the second, and so 4 squared is 16 though. And then I got confused and I was like, well, 16 times 3, I think that's 48, and that's not the same as 16 times f of x, but it is, because this right here, that's f of x. F of x they defined it as being 3 times 4 to the x, and that's 16, so I got 16 times f of x. Okay, so we're going to do the same thing with this one. They're saying show that f of x minus 1, and again we're using this f function. Here, I'll move it so you can't see this other mess. F of x minus 1 is 1/4 times f of x. So again, we're just going to plug in f of x minus 1, or we're going to plug in x minus 1 everywhere we see an x. Then we're going to use the laws of exponents. So it's 4 to the x and 4 to the negative 1. And then 4 to the negative 1 is just 1 over 4. And then instead of me multiplying the 3 and the 1/4, I'm going to recognize that 3 times 4 to the x, well, that's f of x. So I've got 1/4 times f of x. That's what they asked me to find. So I did it. That was number 14. And then number 15... Number 15 says, I think I can make this so you can read it better. Number 15 says, as you saw in the previous problems for an exponential function, a horizontal shift is equivalent to a vertical stretch. To visualize this, look at the graphs below. So they've just got a typical exponential, and they're going to show you what happens. Letter A says discuss these graphs with your team to make sure everyone understands that the graphs demonstrate that for an exponential function, a horizontal shift is equivalent to a vertical stretch. So this one, it kind of shows, see how the arrows are pointing left? It says they took this thing and they slid it so that it fit over here. And this one, see how the arrows are pointing? They lifted it so that it would fit. It says graphs help demonstrate why, but they don't prove. So they want us to do some algebra. So I'm going to do the algebra. So, sorry, my voice is going out. So you can read this. And then I'm going to do the algebra real quick. So first I'm going to take apart this so that it's b to the x times b to the h. And then I'm going to let a equal b to the h. So now I've got b to the x times a, which is basically this. So I'm just showing that these things are equivalent. So if this is b, and I let them switch like b to the h times b to the x just to show that we said b to the h, we let it equal a. So that's a times b to the x. I mean, you can go around and around in circles with this, but that kind of shows algebraically that this shows there's a stretch, this shows there's a horizontal shift, but I can go back and forth between these. They'll do the same thing to the graph. And that's it.